All right, we're going. All right, everybody.
Hey everyone, welcome to Columbus BSides. I'm Aditya Balapure, aka Addy. First time speaker here at BSides Columbus. Really excited. Hope you guys are doing awesome. Cool. So just to give a quick introduction about myself, I'm a security guy at Grubhub. Probably a lot of people might not know about Grubhub. So we connect diners to restaurants. We deliver food and all sorts of fancy things. So go check out. Again, really passionate about information security. Been a builder, breaker, defender, author as well. Love InfoSec. You can reach me on Twitter here. Pretty much a die-hard OS member. So here's my email, and in case anyone's in the NYC kind of community, because I'm from NYC here, I love to catch up on OS meets or just for a drink. So quick question, why exactly are we really here other than the topic? Majorly to have fun, beer of course after the conference, and not right now, unfortunately. And hopefully I'm going to talk about something related to cross-origin resource sharing. Again, I'm not really teaching here, just having a fun time with you guys. Hopefully I'm audible in the back. Okay, cool. So we're going to go over and talk about some of, or unravel some of the mysteries about cross-origin resource sharing. We're going to discuss some of the common developer mistakes which I come across in my daily job. We're going to discuss or go over some of the attacks in the wild, and yeah, beer, of course, as you said, after the party. Cool. Course, or did I say course? Just a quick Wikipedia definition of what cross-origin resource sharing is. Basically, a resource makes a cross-origin HTTP request whenever it's asking for or trying to access a specific resource across a different origin from where it's making the request. Again, this is basically a bookish definition, and we're going to cover more fun stuff and basically go over some easy examples, some lame examples, and even dive into some of the deeper technical request responses and understand the whole way how the whole thing really works. Cool. So just a quick origin. Wrapper around the same origin 101 policy. So pages are under the same origin if they are under the same protocol, host, or port. As an example, here we have abc.example.com being offered over HTTP. So a different origin to it would be a different host. Here, as an example, xyz.example.com. Another would be abc.example.com if it's being served over a different protocol, let's say HTTPS. If it's served over a different port, 8080. So hopefully everyone understands, what exactly same origin and different origin.
Pretty much that's the expedient way of.
So why exactly the whole concept of breaking out of the same origin policy was developed? Nowadays, we're seeing more and more websites being, needing or having the need to share more resources, to have to talk to more of the web services, connect with social media, connect with OAuth and for authentication, all the fancy stuff. We have external APIs, which a lot of users need to talk or share information with. So all of this is making or driving the need for us or the browser to talk over different origins, because again, we cannot restrict it to document or domain restrictions. As I said, more and more companies are moving towards a microservice architecture. As an example here, so we have multiple microservices basically coming together as a single website. You have external APIs being put together and as a main website, and it's just become a feature-rich web resource for a particular user who's coming onto that particular website just to gather information, maybe buy something or do all sorts of stuff. So, and the third reason is, as I talked about, more and more dependence on external APIs. We have social networking. People need to tweet and do all sorts of stuff. We have people need to use just one email address to authenticate. So OAuth providers are important, and basically why exactly or the need is coming. Why exactly we're having the need to talk more cross-origin or share more information cross-origin. Cool. So here's a pretty simple example of how modern architectures of a website really look. We have a user browser coming onto the main website, and the main website is basically a collection of different microservices, external APIs, social media, and all sorts of fancy stuff all put together. So how does it really work? We went over a bookish example of cross-origin resource sharing. Let's try and maybe help you understand this particular theory in a more kind of lame way.
Is it possible to dim the lights up front? Oh, sure. It's a little hard to see.
There we go.
Yeah.
Cool. Yeah. Okay.
Sorry,
Sorry.
I'm blind.
So here we have a user browser, or let's say, since it's a simple example, we have a user. The user is basically coming to a store A, and what the user wants from store A is basically some chocolate cookies, right? So he comes to store A and asks for some chocolate cookies, but store A is saying, "Hey, I don't really sell those, but my partner does. So let me ask those chocolate cookies from my partner." Store A, what it does is basically, asks for those particular cookies on behalf of user, that, hey, can I get some chocolate cookies from my nice friend? And I'm an authorized seller of your product. You can go back and check. Store B says, hey, hi, thanks for coming in, and just goes back and checks whether, he's an authorized seller. Yes, once he checks that yes, he's an authorized seller, he sends back to the user some chocolate cookies, and everyone's in a happy state because ultimately the user got his chocolate cookies. Store A was able to fulfill the request. Again, store A and store B, think of it as different origins, where store A, where the user came to store A, but the request is ultimately being fulfilled by store B here in forms of chocolate cookies. It's a pretty simple example, and we're going to dive into more deeper technical examples here. So when we talk about course request, the concept of simple and complex mainly come up. Simple from the word simple, or pretty simple. Sorry for repeating the word. So here we have a GET request to the URI abc.example.com /get my stuff. Simple HTTP request, pretty simple user agent headers. If you see the origin where it's coming from is www.example.com. It's making the request to abc.example.com. The cross-origin server responds back with a response HTTP 200. And also, if you notice, there's an access control allow origin set to star. Again, we're going to go over and discuss what's the importance of the access control allow origin, what basically the star wildcard means here, and what can be some of the security implications of the star wildcard. So it's a pretty simple request response happening. The server is basically responding back that, hey, I'm allowing this origin, in the form of star. Basically, star here signifies that I allow any and every origin for accepting cross-origin requests. So everything's good. Here's your response. Here's your data back, and we're all set. So since we discussed simple requests, right? Next really comes the concept of pre-flighting, or just to understand how complex cross-origin requests really work, we need to understand the concept of pre-flighting. So complicated requests technically usually mean if it's being any sort of request other than a get head post. Maybe examples like if the user browser is trying to update a resource through put, or if he's trying to delete a resource through a delete request. If the request contains any sort of different content types, let's say if the browser is trying to pass on JSON, XML, or any sort of data, and if it's not talking about text plain, then it needs to go through a pre-flighting. If it's trying to set any of the custom headers that need to be sent, if it's an authorization header, if it's any sort of custom things which a resource is trying to do, you need to go through a pre-flight process. To understand CORS or cross-region resource sharing, we just need to be aware of some of the core jargons of the cross-region concept, just to understand the deeper technical examples and some of the attacks. So when we already covered the pre-flighting concept of how exactly or why exactly the pre-flighting is required. As I said, if it's a complicated request, it needs to do fancy things other than get it post. It needs to go through that. If you're passing any sort of application JSON kind of data, you need to do a pre-flighting. So when a pre-flight really happens, a browser request sends an access control request headers. It's basically checking with the cross-origin or making sure with the cross-origin server what sort of headers is he allowed to pass. So that's the access control request headers. When the other important header here is the access control request methods, just checking with the cross-origin server that, hey, what exactly methods am I allowed to make a request with? Is it a get, head, post, delete? What exactly specifically do you allow? You can specifically whitelist different methods across different resources and origins and things like that. We're going to cover more deeper examples of that. The access control allow origin, as I said, where the cross-origin server responds back saying, hey, if it's a star, it means, hey, everyone is allowed, go ahead, make the cross-origin request and you're all set. If it's specifically whitelisting some origins, it could be responding back, hey, I allow www.example.com through a cross-origin request, so you're all set, you can make the request. If it's dynamically loading that particular origin, it can pass it back. Again, there are security implications in that. So all sorts of this fancy stuff can happen across the access control allow origin header. The access control allow headers, again, basically means what specifically headers you're allowing to pass back. If there are any custom headers which the browser needs to set, these can be passed through that. The options request is pretty much the pre-flighting process where the browser sends in a request to the cross-origin server. The cross-origin server responds back saying, hey, these are the things you're allowed to make. These are the requests. These are the type of the methods you're allowed to send. Or these are the, these are the data that you're allowed to send me over. This is pretty much the pre-flighting kind of sequence. The access control allow credentials is, again, a pretty important header. What it says or what it means is whether the browser is allowed through that origin to make credentialized requests. Now, in order to make credentialized requests, basically request with credentials, and these could be like any sort of session information, cookies, and things like that. Basically, to make the cross-origin server aware that, hey, this is the user, he has already a presence through the session information. Is he allowed to make that request? So the browser checks that, the cross-origin server responds back, hey, you're allowed to make this credentialized request, and, we're going to cover some of the examples through that as well. But, yeah, these are pretty much the course terminologies which we need to be aware of in order to understand the deeper technical examples. So, time to dive in and how specifically a complex request really looks like. So, as I said, we have the pre-flighting process which the browser makes. As part of the pre-flighting process, it's basically an options request to the abc.example.com/authenticate URI. We have pretty simple, pretty common user agents, accept headers, language, encoding stuff. We are also requesting with the header access control request method post, which basically the browser is requesting or asking for permission to make a post request to that particular cross-origin server. We also have the access control request headers, as we discussed, that, hey, cross-origin server, am I allowed to pass in these headers to you for a successful request? And as you said, the user came through this www.example.com origin, this origin is being passed through the user browser. Again, this is the pre-flighting part and not the actual request. So once the pre-flighting request goes through, what the cross-origin server responds back is basically a 200 saying, hey, you're allowed to make credentialized request to me. You're allowed to pass, XYZ headers to me. You're allowed to send me these requests or these methods, basically a head, delete, post, get in this particular case. If you specifically see the difference here, we're seeing the access control allow origin header set to www.example.com, which really means that it's specifically whitelisting or making sure that cross-origin requests are just allowed from the www.example.com domain. Cool. So after the whole process of pre-flighting is completed, they do the initial check that okay, I'm okay. The browser is okay to make this particular request through these particular methods. So now the browser goes ahead and makes a post request again to abc.example.com /authenticate URI, again with a bunch of user agents and normal headers. And we see here the origin header is set as www.example.com, and it also sets JSON blob in the request. Could be credentials, could be any data which it's requesting, and waits for what the browser is responding back. So what the browser does, the browser responds back with an HTTP 200 saying, hey, you're allowed to send me credential requests. These headers are allowed. Everything looks good, as we said, and here you're all set. Here's your data. Basically, it might be making a login request or any sort of, it could be asking for API keys or anything like that. The cross-origin server responds back saying, hey, it looks good, and I authenticate you, and you're on allowed origin. So here's your data, which I am giving back. As an example, it's a pretty simple JavaScript snippet. What it's doing is it's opening a post request as an XML HTTP request, and basically sending a cross-origin request to abc.example.com /authenticate again, as we covered in the previous example. How it works with Google APIs, they also allow cross-origin requests. So here's an example of a cross-origin request to people.googleapi.com with an access token. As we said, it's part of credentialized request. The user is trying to, or the user browser is trying to make a request on behalf of the user, adding his access token and getting some connections and getting some data back from the Google cross-origin server as part of the credentialized request. So as we covered, there are developer mistakes which can really happen across these cross-origin servers. And again, as we covered the example here, when the cross-origin server responds back with an access control allow origin set to star, what basically does that mean? It basically means, as I also talked previously, that it's allowing any and every server to make a cross-origin request to its resources. So there could be implications because, if you're trying to protect any resources, or if you're unsure that, you might be publicly allowing this particular resource to be available to anyone to make that particular cross-origin request, this could be really bad. Because it's not really a form of, protecting your resources for any sort of authentication or authorization. If you're planning on doing that, please don't, because you'll be ending up, getting requests and responses back and forth from any and every domain, which is not really wanted here. Because it's not a way to protect resources. You could whitelist specific domains where you want your request to come from. So if you want to do that, we're going to talk about credentialized request, as we said. Again, the star wildcard is really not a good way, or unless you're just basically giving access back to some of the public resources, or you don't really care about what data you're sharing with the user back. again, if the website is vulnerable to any sort of if the cross-origin server is vulnerable to any sort of cross-site scripting, cross-site request forgery, this could be again bad because you could be ultimately making request on behalf of the browser, which the user is really not aware of. So if you're allowing the star wildcard, please make sure you're only allowing specific functions which are not privileged functions. You know, it could be some public functions which you don't really care of. So if you specifically want to allow any protected resources, make sure you ask for credentials, ask for cookies and things like that, basically to protect the user here in this case. Here's a simple AWS S3 examples, how it can be configured for allowing cross-origin requests. So as we see here, in the first case, the allowed origin is set to www.example1.com. You know, it allows put, post, delete methods. In the second case, it allows example.com, which basically allows, again, put, post, delete methods. But in the third case, it's specifically allowing the star origin to receive all sorts of GET requests. So again, if you're doing that, you know, a lot of times I come across configurations where they don't really specifically whitelist origins. They basically say, hey, it's set to star, I'm happy to allow resources, and then they'll be dealing with API keys, any sort of protected data. So please don't do that. You know, if you're trying to protect resources, if you're trying to allow only specific domains, make sure you put that in the configuration before you allow that particular request to happen. Developer mistakes too, which usually happen if you're making any sort of credentialized request. You're passing on cookies, you're allowing access to protected resources. Make sure you're specifically whitelisting domains. You're not trusting the domains like that. You know, again, we're talking about cookies being passed on behalf of the user, giving access to protected resources. As an example, we say here, it's a post request, again, an XML HTTP request happening on behalf of the user, where the user browser is basically adding a cookie, a token in this case, you know, as making the cross-origin server aware that, hey, this is me coming in, and please allow this request to pass through. So if you're dealing with any sort of these kind of circumstances, make sure, you know, the browser checks for the access control allow origin here in this case, which is set to evilhost.com. This could be really bad because if we think about this example here, a user browser which comes to a malicious web page, an evil host is basically loading any form of JavaScript snippet, right? If he's loading any sort of JavaScript snippet, which is again a cross-origin request which is happening to a super secret server, let's say, you know, it could be banking, it could be any sort of, you know, maybe an API request to get some credentials, to get some API keys or anything like that, and the super secret server doesn't do the right things which it needs to do, right? It basically just responds back or reflects back the origin server where the user really came from. So if you see here, the origin is set as evilhost.com, which basically means that the user came to evilhost.com, you know, he was browsing the website, and then an XML HTTP request just kicked in, made a request to the super secret server, and the super secret server didn't do its right set of things in order to check or make sure whether the request was true. So basically, this ended in the browser adding his user cookies and making that credentialized request and getting back a response. You know, it could be secrets, it could be API keys, it could be any cool thing, you know, which the cross-origin server isn't really knowing that what it's passing back to the particular user. So make sure you don't do this kind of mistakes here, which is pretty common. You know, a lot of bug bounties and stuff like that usually happen, and you know, you see CSRF tokens being passed because again they're not validating the token. whenever they're protecting cross-region resources as through CSRF requests and stuff like that. So make sure you validate these specific origins. The third mistake which I usually come across is origin mess-ups. As we saw, people blatantly just allowing the star origin to be responding back from cross-origin server. They don't really validate the origin right. Again, they don't really manage the whitelist of what specific origins they're allowed to make the requests from, and hence they end up making requests or responding back to any domain. They at times just dynamically load the domain. So let's say a request comes in from evilhost.com, they don't perform any checking, and just respond back with, hey, evilhost.com, you're good, you're all set, make that request. So please make sure you're not really blindly trusting the origin header here. You're performing some sort of checking to make sure if it's a privileged function, you're only allowing or accepting requests and responses from only specific origins. Cool. That's pretty much it. And I can take in questions if anyone has.
What kind of support have you seen for
Can you be a bit louder?
headers in clients that aren't?
Can you be a bit louder?
Have you seen support for these headers in HTTP clients that may not be browsers? Say like what this HTTP stack in your favorite language?
No, not really. No, not really. Yeah. It's more of the browser thing.
Yeah.
Can you recommend any training resources for developers to go and learn more about this so that they know the correct way to do it?
Sure. So the Mozilla, there's a great documentation on Mozilla how to do it the right way. And also, if you're using any sort of AWS resources or, you're planning or developing any sort of AWS services, you're using the API gateway or you're developing or creating a website on S3, they have a great documentation to do it the right way.
So this is intrinsically in a cloud hosted
Yep.
SDR defined or SNR defined
Yep.
environment.
Yep.
I.e. traditional hard iron. Well, you're not going to run across this quite much in a hard data center type of scenario.
Yeah.
Is there a scanner you use to check for these sort of vulnerabilities, or are you just doing packet capture, or what tools do you use?
So it's I think the scanners are coming up with signatures to get these particular, like a lot of these automated scanners. I remember Burp scanner now captures if the server, cross-region server responds back with star saying, hey, making sure if you're not allowing any privileged resources across the specific origin. And I think there's another one. I think check marks as well allows or checks if you're allowing access to this particular resource over as responding back with a star. So there are scanners automatically coming up with time and stuff. But there is you need to again eat your pen testing veggies in one time and make sure you're pen testing it properly. Walking across different scenarios. Making sure you're testing things and you're not able to bypass, because a lot of times what happens, people usually end up making regexes for origin checks, and a lot of these regular expressions are not that good, and they just end up allowing things which shouldn't be really allowed. Let's say if the request is only allowed from host.example.com, it ends up getting allowed from evilhost.example.com because it's just ending up with the word host.example.com. So again, there could be multiple scenarios, and a lot of these automated scanners don't really, catch these particular circumstances. But again, if you can go through the manual route and basically test and check for various use cases. I think it would be good.
Is there a variety of different stacks that can be applied to, i.e. like REST stack or those APIs?
Yep.
JSON predominantly is what XML.
Yep.
Okay.
Yeah. Yeah. So this is one thing which is really coming up in terms of people not being really aware and just allowing these kind of resources, and they end up basically exposing all sorts of stuff like secrets and things and all sorts of fancy things across the region.
Do you see in the training the newer developers getting more sanitized input checks and that kind of more secure coding techniques? Do you see that coming up, or is it still a bleak hole in its current state of affairs? Are you seeing better?
It's getting better with time, I'd say. A lot of these static analysis checks now make sure that they perform any sort of, even if it's a false positive, they alarm the user. Even if it's like server communication, if the user is not really involved in here, it's not a browser or it's not reflecting back to a browser, they still come up with checks to make sure, you're not really, passing back the data without sanitizing. So, yeah. Cool. Thank you, guys.
Thank you, sir.